Good day guys. In this video we are going to discuss about data structures and algorithms. I am going to concentrate more on its real life applications so that you can better understand the importance of data structures and algorithms. What is a good program? A good program is a combination of both algorithm and a data structure. An algorithm is a step-by-step recipe for solving a problem. And data structure is a way of storing data in an organized way so that we can retrieve and process the data easily and efficiently. A good algorithm should complete a task with less time and less space. That is, we have to concentrate on its time complexity and space complexity. So, time complexity of an algorithm is the amount of time needed by a program to complete its task. And space complexity of a program is the amount of memory consumed by the algorithm until it's complete its executions. Now we're going to see the type of data structures. There are two types of data structures. One is linear data structure and the other one is non-linear data structure. So data structure in which the data elements are arranged sequentially or linearly, where each element is attached to its previous and the next adjacent element is called a linear data structure. Some of the examples are arrays, tags, queues, linked list, etc. And what is non-linear data structure? It is nothing but the data elements are not placed sequentially or linearly. That is, we cannot traverse all the elements in a single run. So examples, for example, we can say trees and graphs. So now we are going to discuss about some of the linear data structure. And the first one is arrays. Arrays are the simplest data structure that store items of the same data type. For example, the contacts on the cell phone, the CPU scheduling in the computer, and the storage of images of a specific size on Android or laptop, mailing list, etc. Next, the second one is stack. It is a data structure that uses LIFO, last in, first out order. This means the last element inserted inside the stack is removed first. For example, we can say forward backing surfing in the browser, message logs and all messages that are arranged in a stack. And the third one is the queue. So it is a data structure that uses FIFO, first in, first out. The item that goes in first is the item that comes out. So some applications are operating system that uses queues for job scheduling, sending an email, it will be queued, and server while responding to the request. The next one is linked list. So it is also a linear data structure which connects the elements called nodes through links. Here each node stores the data and the address of the next node. To give some examples, we can say history of the visited pages, to perform undo operations, escalators. It is an example for circular linked list. So we can give many examples for that. The next type is non-linear data structure. As we already told, trees and graphs will come under it. What are trees? Trees are nothing but hierarchical structure that have a single root node. To give some example, we can say databases that it will use indexing in the form of a tree structure, DNS, domain name servers, file explorer, my computer of mobile, any computer, etc. The next second type of non-linear data structure is a graph. It is a data structure where data is stored in a collection of interconnected nodes and edges. So to give some examples for graph, we can say Facebook's graph API, it uses structure of a graph. The GPS navigation system also uses shortest path APIs. Data organization, Facebook, Instagram and all social media networking sites, it uses the node concept. And now we are going to see some of the types or methods of algorithm. The first and foremost is the divide and conquer algorithms. Sorting algorithms like heap sort, quick sort, merge sort, problems like searching an element, finding the maximum and minimum can be solved using divide and conquer. So what are the applications of sorting algorithms? Applications, we can say playing cards with your friends, contact list on the phone, online shopping. So these are all some of the examples for sorting algorithms. The second one is greedy algorithm. The greedy algorithm, it is an approach for solving a problem by selecting the best option available at the moment. It doesn't worry whether the current best result will bring the overall optimal result. What are the applications? We can say Dijkstra's algorithm, shopping on a tight budget but want to buy gifts for all the family members. Prim's and Kruskal's algorithm are used for finding the minimum spanning trees, etc. So the next algorithm is backtracking algorithm. Backtracking is an algorithm, a technique for solving problems recursively by trying to build a solution incrementally, one piece at a time, removing those solutions that fail to satisfy the constraints of the problem at any point of time. So the idea behind the backtracking technique is that it searches for a solution to a problem among all the available options. That backtracking at every step, it eliminates those choices that cannot give us the solution and proceeds to those choices that have the potential of taking us to the solutions. So what are the applications of backtracking? We can say Sudoku solver, computer networking, N-Queen's problem, so to find the Hamilton's path, etc. So to sum up, for a good program to execute, we need data structures and algorithms. So if you learn data structure and algorithm, it will be helpful while creating a program. Thank you.